forgot about the sine and the cos. And Fahad? That's a pretty big thing to forget though.
Because everything else was error carried over.
Yes, it was. Big error, too.
So we didn't give you the mark.
I'll have to look at the marking scheme. I don't know. It's a pretty big error because it's on a plane. You have to resolve it. You have to have the I and the J. But let me draw it. Okay. What's the angle here? No, Fahad. Look up. What's the angle here? 25. Thank you. 25. And what's the length here? 30 meters. So can you get the base and the height? You can. 35. What's the base?
Cos inverse.
No. 30 cos 25. 30 cos 25.
Yes.
No inverse. 27.19. And the height?
Sine 30 times 25.
So the height is 12.68 meters and meters.
We don't need it.
Oh, we do. Because there's a smart way to do this one.
There's easier way.
This is the easy way. Here, at the top, what's the speed of the block? 4.5 meters per second. And the mass?
6.75.
At the top, what energy does it have?
Potential and...
It has potential and kinetic. And at the bottom, what energy does it have? Only kinetic. So, to recap, do we know the M?
Yeah.
G?
Yeah.
Height?
Yeah.
Half?
Yeah.
Mass? The initial speed?
Yes.
Half?
Yeah.
M? B? What do we want? B, yeah. Can we easily solve this? In fact, I can cancel all the M's. So I didn't even need to know the M, and I could also multiply by 2. So I'd have 2GH plus U squared equals B squared. So if I get the B, what do I do? Square root. Yeah, that's what I'm talking about. Let's see if we get the right answer. What was the U?
4.5.
What's the answer in the book? Which is exactly what I got.
Question.
Yeah.
Can you explain to me why at the first has both potential energy and...
It's potential energy because it's above the ground,
Okay.
and it's kinetic energy because it's already moving at the top.
But at first it is both.
No, it is moving. It says it. It's initially moving with this speed.
Okay.
Can I ask?
But what? What's wrong with it? Don't you like this way? Yes?
Yes. So I have the formula V squared is equals to U squared plus 2S, which is like the same thing here.
Yeah, but what's the A? It's
The
not 9.81.
The A is cos.
A is not 9.81 because it's what's happening here, KJ, is that the A is going down 9.81 meters per second squared, but you don't care about this part. You want only this part, the motion along the plane. So you actually, to fix your formula, need a 9.81 sine 25.
So that means the 30 will remain the same.
Yes, you try to change to 30.
Yeah.
Way off. Do it this way. I like this way. Simple. Why do you look confused about this simple way to do it?
No.
Why don't you multiply by mass?
Why do I multiply by mass?
Well, acceleration should be energy equals...
No, that's the force. Question withdrawn. Can I go? Oh no, I can't. What do they want next? What's the form for momentum? Correct, MV, MV, VM, whatever. And do you know how to multiply two numbers? Are you more than 10 years old?
Yeah.
Yes, so the answer is 61.51 kilogram meters per second. Yes. 2 marks. So altogether, you're looking at 5 marks.
Maybe it's 2 marks because in case you carry an error code, we can give you 1 mark.
Please stop talking. Now, the next part is how long until it reaches the bottom of the slope. Yes? Yeah, now look. Hey, dudes, look up. You have a U, correct? Do you have a V? Do you have an S? Do you know the A? You could, but technically I don't, because I don't know the acceleration in this direction. I only know the acceleration in this direction, not in the diagonal direction. So what's the U? 4.5. The V?
16.4.
T, don't know. S, I don't know. A, I don't know. S, we do know, actually. It's 30. And what do they want? So which formula? S equals, no, V squared equals U squared plus 3. Yeah, I know. And I asked you which formula. No. Yeah, S equals UT? No. No, I said U plus V over 2 times T. This one. Yeah, really, because we know U, V, and S and we can get the T. What's the time? Let's see. U plus... What? Why, KJ, what's the attitude problem? T, when you solve it from this equation, you get T equals S over U plus V over 2. So when you put in the S, U, and V, you get the T is 2.87. What's the problem with you, KJ? You don't like how easy my way is? Because the way in the marking scheme is much more difficult? Yeah. So this is why you come to revision class, you know?
The acceleration here is the same?
Well, I don't know what it is. I never worked it out.
No, I mean like it's apply the same formula sign?
Oh yeah, but I'm not even bothering to work it out. I don't need it.
Yeah.
Yes, it would be the 9.81 sine 25, I believe. Yeah.
9.5.
Yeah. Pretty easy 4 marks when you really think about it a lot.
Yes.
Now, you see, you're all sitting there going, oh, but I thought this was so difficult. And you're now thinking, oh no, I'm screwed. Yeah.
The way you did
Practice, yeah?
the way you did this is very easy and familiar to me, but it didn't come out in the exam for me.
This way?
Yeah, it didn't like...
Well, it came up last year, so...
Huh?
Came
I
up...
mean, the way you did it didn't come up to my brain.
That's you need to practice more.
Okay.
Don't worry. The first time I did this, I actually did this question with the January students a month ago, and I actually did it the way he did in the marking scheme, by resolving the components. And then afterwards I realised, I wonder if there was an easier way to do it, you know. So that means now if I see something like this again in the exam, I need to remember I can use energy to help. It's much quicker using energy. And in fact, you'd be surprised, but motion in a plane, inclined plane, actually came up 3 or 4 times, you know, so I think there's a reasonable chance that you could get something like this. It's not impossible to see it again. Right, the B part. Now, the B part is tricky. I don't expect you to get this one. Let's look at it.
This is 3, 4, 6.
Wait. Let me draw it first, okay? Now this one, okay, are we looking? So what's happening here is you have a ball and it's thrown horizontally.
Yeah.
So it goes black like this. Its speed here is 12.25 meters per second. Do we know its mass?
Yeah.
No, we don't. And I guess we don't need to know it. Now this question, they want the time and the distance for it to arrive right here.
Yeah.
At the end.
Yeah, oh, it doesn't really matter. Like if you look at the diagram, the slope goes down to infinity. If you look.
The slope, like, at the end, which point of the slope?
No, it doesn't matter. Just some distance down the slope, which they call h.
The standard distance, like, for example, 1 meter, 2 meters.
I know, and this is what they want. What's the distance? Right. So ultimately, what type of problem is this? It's a projectile problem, isn't it? Ultimately. So we have a horizontal UVATS and we have a vertical UVATS. So horizontally and vertically. Horizontally, what's the U?
12.25
That's
sine.
B? No, 12.25.
Only x. Horizontal.
The X. What's the V?
No.
Don't know. What's the A?
0.
0. The T?
9.
Don't know. And the S?
No.
No, H. Don't make me come over there and slap you. What is it?
range.
Well, we don't know it. We don't know. So, what I'm going to do is, now just think about this. This is where you have to activate the parts of your brain called thinking. Okay? So, what are we looking for ultimately? The time and the hypotenuse, the H. But of course, with projectiles, we can only deal in the horizontal and the vertical. So his question of finding the H is really the same as finding the X and the Y, horizontal and vertical distance traveled. So I'm going to think about this as a problem of finding the X and a problem of finding the Y. Now we have to be careful because the Y will be negative, but we can deal with that later. Vertically, what's the U?
Sine.
12.5 something.
I'll just wait until I hear the right answer. Vertically, what's the U?
Cos.
12.25.
25.
The V? We don't know. Minus G. Yeah. T, we don't know. Although we do know at least it's the same time as that one there. At the
We
least.
can equate those.
We might need to. We might need to. We might need to, yes, yes. So this is T and this is T. In fact, first he wants the T. So what equation should I use here of my 4 equations? Well, we have to use the one that has a U and an A in it. Because V equals U plus AT. No, because we don't know the V. We have to use, we want one that has in it UAT, ideally. An S, maybe. I think S equals UT plus a half AT squared will do nicely. So here, S equals UT, yes, plus a half AT squared. And here, S equals UT plus a half A T squared. So I have X is 12.25 T and Y equals minus 4.905 T squared. And the minus because it's going underneath. We shall pause for a moment for you to catch your breath and then we'll continue because there's more to do here. So just take this much down first before I progress. Are you ready? Because you're going to see some magic next. Take that off. Yeah, come on. Take. Remove the wire from your head. Thank you. Right, next. Right, so, tell me this. If I just redraw my triangle, this triangle here, how big is this side, the x? It's 12.25t. And how big, now wait, don't do that thing where you just answer without thinking, okay? Think please. How big is the height of this triangle?
Minus 4.905.
It is 4.905 t squared. Why did I drop the minus?
Because it's downwards.
No. Well, it's because I want the length of the side of the triangle. How long it is. I don't care about the sign. Positive only. Right, what angle is here? 25. Now, you know, this is really going to be, now you see me magic, okay? Just brace yourself. I'll do it over here. What is tan 25 equal to? 4.905 t squared over 12.25t. The t's cancel, and you get t equals 12.25 tan 25 over 4.905.
Boom.
Now you would never have thought of that, right? But now if you see something like this, you know this is how to do it.
Then one do that before?
I think this is a new question to the exams, Karar.
That's what it's called coefficient.
Yes, it is. This is exactly the reason
That's why you
why.
don't get 1 week free before exam.
Yeah, actually, it's much better to be here. 1.165 seconds. Now, the next part. Now, this is a really great thing. That was 4 marks, and that's a lot. But the next part, how much is it? So, all you have to do to get the extra 3 marks is to take these values for time, put them in here and here, use our buddy Pythagoras, and we've got the hypotenuse. So, if I just maybe redraw that triangle, or if I just get the sides here, so the base will be my time 1.165 times 12.25, so the base is going to be 14.27 meters, and the height will be 1.165 squared times 4.905. So the height is 6.657 meters. So the hypotenuse from Pythagoras is the answer 15.7 meters?
7.5.
Yeah, 7.5 if I do the 2 decimal places. Now, I think that would be a difficult but not impossible mechanics question. Yeah, 4 left. Part C now.
So here, they read the two distances equal.
No, they didn't, did they? X and Y.
Yes.
But they're not equal. They didn't make them equal. What do you mean to make them
They
equal?
changed X to something else. I don't know how they did.
No, the way that's in the marking scheme is crazy difficult. I know what they're doing. They're doing it in a way that I feel is inappropriately difficult for the physics course.
It's almost the same way you did because you just did.
It's almost the same, but I think it's different enough to make it maybe too confusing to follow because, well, you're asking me right now what did they do.
They will give tan like 12.25 T times tan 25.
12 point,
12.25 T, that's the F times tan 25
equals
equals
y.
yes equals y.
What they're doing is, they're doing a bit of trigonometry. I tried to do this question using the minimum amount of trigonometry. I just used the tan formula once and a Pythagoras once. Whereas in their solution, I think they resolve.
Just once.
Is it just once? Okay.
Just that really one.
Okay, fine. Well, I don't know. I like my way. Do you like my way? Of course you do. Right. Part C now? Part C?
Yes.
Yeah. Okay, part C now. So part C, we've got a 2.45 kilograms, and there's a force here of 150 newtons, but the force is only for 0.2 of a second. What is the impulse? Okay, what's the formula for impulse? F delta T. Is that 30 newton seconds? Yeah, okay. And then part 2, is it 30 kJ?
Yes.
What's the velocity?
Divide 5.
Well, there's another formula for impulse, do you remember? mv minus mu, the change in momentum. What's the momentum at the start? I think it starts at rest, does it? Disgraceful. They should have said it's at rest. Anyways, it is at rest. So I'll knock the mu part off because it's 0. Do we know what the I is?
Yes.
Yeah, and do we know what the m is?
Yes.
So could we know what the v is? That's right, we could. Is it 12.24?
Yes.
Did they do it like this as well? So this mechanics question is a bit of a mix of a question. It has good parts and it has bad parts, but I hope after seeing it done you realise it wasn't as bad as it seemed at first. Again, the importance of practice. Close.